of the today's lecture, right? So because we have 34 students, so okay, remaining will be joining soon. So the focus of today's lecture is this very maybe relevant or important concept of database design, because in this our focus or the whole purpose of this activity is to make the database and make the database table operational, or maybe make our database table in a way that we can apply different operations, different user operations, right? So like in the previous classes, we have taken two important concepts. First one is to derive or identify all the possible functional dependencies in a relation, right, in a database table. Like we have clearly pointed out that in a database, we could have multiple database tables, and we should be taking one table at a time, one database table at a time, to identify the FDs, and similarly to identify the key. And similarly, in the last step, whenever we want to normalize this whole database, we should be focusing a database table at a time. We cannot go for the normalization of whole database, right? So we should be, it is like conducting a for loop. So you have to take one database table from a database, and then first step is to identify FDs, second step is to identify the possible candidate key, and the last step is to normalize that database table. So once we have done with this first database table, you can go for the second database table, and likewise, right? So normalization is a process. It is not an iterative process. It is a once, basically this process is a once in a lifetime of database kind of a process, right? So because eventually we will be making this database in a certain normal form, certain stage from where we can conduct, or from where we can apply these user operation on the database, right? So today we are going to discuss the last step of database design or data design, because we have started this discussion on the last 3 lectures actually. So today we are having 4th lecture on data design theory, and normalization is the last step of this theory, data design theory, right? So in the previous class we have discussed basically all the aspects based on which we can identify the different functional dependencies based on the data, this relation between data values of 2 attributes, and based on the constraints or keys defined into it. After that, we have covered how to identify the possible candidate keys of a given FD, right? For a relation, for a database relation, suppose we have derived some set of FDs between the attributes of a database relation. Next task is to identify the candidate key. So why we are identifying candidate key? The purpose of identifying candidate key is to make sure that by using these 2 or 3 attributes, we will be able to access each and every value in the database relation, right? Because eventually these 2 or these 3 attributes, which are part of candidate key, will be used to derive or to perform any operation on the database table. So that's why we have to come up with these set of attributes, which we are referring as a candidate key. And we have correctly pointed out that candidate key is having different purpose and primary key is having different purpose. So you should be always careful that whenever someone asks, okay, what is the difference between primary key and candidate key? So you should be having clear idea that this is the purpose of primary key and this is the purpose of candidate key, right? So candidate key is used to identify or to spot the relation between each and every value with candidate key, right? So these candidate key attributes will be placed to the user GUI, so that user can supply the values for these 2 or 3 attributes, and based on that you can fetch the each individual cell values, right? So naturally, when we are saying that we have identified candidate key and we are able to access each and every value by using these 2 candidate key, now you have to basically normalize, or you have to decompose your database table by keeping these candidate key in your mind, right? That naturally this candidate key is derived by using functional dependency, but it is not necessary that each and every database table is aligned to this candidate key. Now you have to perform some kind of decomposition of a database table, and that is what about all about this normalization theory. So normalization is a process to decompose, to basically split a database table, and align it to a certain conditions, right? To perform this task, we have candidate key with us. So to perform normalization, we will be using candidate keys. right? And now how to use these candidate key to perform normalization? Those conditions, those set of conditions instructions are referred as a normal form, right? So initially your database table will be in the form of unnormalized. It is basically created, it is raw form. Now if you want to perform normalization, you have to follow some conditions, right? So there are various normal forms, we will be discussing it with, and each normal form is a set of condition. It is a simple condition, right? Like first normal form is say something, second normal form says something, third normal form says something. So whenever we want to normalize our database table, we have to see the condition of certain normal form, and if that database table is following that condition, it means that particular table is in that normal form, right? So we will be discussing it, and so let me first share the content for the class discussion, and based on that we will be exploring each and every aspect of the discussion, right? So this is the focus for today's lecture, this normalization and different normal forms. And there's two concepts which is called dependency, preservation, and lossless. So we will be taking each and every point in a specific way, right? So yeah, let me maximize this. Okay, so normalization, as we have just taken out, that normalization is a technique. It is a technique to organize. Now, it is a technique to organize, though we have a database table which is organized in some way, but again, we are normalizing our database table. We are organizing, basically we are reorganizing, because एक बार तो हमने database table create किया है, उसमें data value insert किए हैं, तो जो भी available है data का snapshot, it is already organized in some way. It is because it is a relational database, so it is organized. Now we are making it more suitable for transactional purpose, right? So it is a technique to organize the content of the table, content of a database table, right? And it should be suitable. So the purpose of organization is to make it suitable for transactional purpose, right? So suppose there will be some operation by user or maybe multiple user on this database value or database attribute, it should be suitable enough, right? Suitable means when actually in the last lecture we have taken out this concept that whenever we are not performing data design theory, there will be some redundant value, there may be some null values, there may be some other values which will be creating some anomalies, some problems. So this first point is correctly pointing out that we have to reorganize this database table, and in the process of reorganization we should be removing these redundant values, these null values, so that our database should be suitable for transaction to users operation. It should be suitable for user operation, right? After that, actually, so what are the different internal advantages or benefits we will be getting after performing this normalization? So when we will be normalizing a database relation, the first task is to naturally so initially you will be given a database table, and after performing normalization or during the normalization, we will be arranging data, maybe attributes, into logical grouping. So we are splitting it. We are splitting the basic relation or the basic database table, and will place in each set of attributes or set of different attributes into different tables. So initially we will be given a database table, and after this normalization we will be splitting into maybe two or maybe three database relation, right? That is the whole purpose of, that is the whole way of performing normalization, right? So naturally the advantage and the purpose of it to minimize the amount of duplicate, which we have set as redundant also. So let me place here redundant data. So redundant is stored data. So that is the first important purpose. Whenever we are performing normalization, it is always to attack or to reduce this duplicate or redundant copies of the data, right? Because this is what we are facing. Because when we have created the database, when we have uploaded the data values, these are the possibilities that we have duplicate or multiple copies of the same data values of same attribute also. So the very first purpose of normalization is to remove these values. Similarly, so basically we have to, so by placing, so if we have duplicate values, and normalization process is reducing it by splitting it to different subtables or different tables, it is naturally make it suitable to modify. So because whenever we perform modification on this database table, the effort will be less. That's what we are intending. That's what we are wanting to be done. So because if we are not doing this, it will cause those three anomalies, right? Delete, insert, and update anomalies, right? Similarly, if we place data of a single table into multiple tables in a very isolated or in a very arranged manner, whenever we perform something, whenever we perform accessing, so suppose there is a access request to the data value, it will be more efficient. Similarly, if we perform some manipulation, it will be more efficient because we are not having these multiple copies. We are having lesser database attributes in a table, subtables. So basically, whenever we perform normalization on a database table, the eventually objective is to achieve a data table which will have lesser duplicate and redundant data, a database table which will have lesser number of null values, so that we can perform database access and data manipulation action efficiently, right? That is the whole purpose. So if we not perform normalization, if we go with the same data which we have created during the data creation without data design theory, we will be having a inaccurate, slow, and inefficient database tables, right? Which will be basically creating a lot of headaches to the database management softwares, as well as a lot of problems to the user also, right? Now, naturally, so let's brief it actually. So when we perform normalization, when you perform normalization, you start from a general and right. So you will start with a general database table and work towards a specific. So specific means we are trying to split it. That's what specific means. So when you start from a general database table and work towards the specific database table, so in this process we will be applying some kind of condition or constraints, and these condition or constraints are referred as a normal form. So normal form is a term actually. So normal form, whenever it is asked that what is the normal form, you can simply say normal form is a set of condition to be performed, to be checked on a database table, right? Like in the data, like when we were discussing what is the constraint, database constraint, what is the primary key. So primary key is nothing, it is a set of condition, it is a kind of check, right, in a database table. Similarly, if someone say what is normal form, you can say normal form is a set of conditions which needs to be checked on a particular database table. All right, so whenever we will be performing a normalization process, we will start with the basic database table, and we will intending to achieve a specific database tables by applying these normal form, by applying these conditions, right? So this process is often referred as, so it is equivalent to normalization is often called a decomposition process also, because we are decomposing, we are splitting the database table. अगर आप database में कभी search करेंगे Google में, तो there is a process called partition also. So database partition is a different process. It is nothing to do with normalization, right? But normalization is because to perform normalization we will have these normal forms. But in case of database partition, there is no such condition refers. You simply partition a database table horizontally or vertically based on some need. But normalization is altogether different process, because to perform normalization, we have these normal forms. We have definitions, we have set of conditions for each normal form, right? So eventually, the purpose, the effect of this decomposition is naturally is to eliminate insertion, updation, and deletion anomalies. That is the theory. That is the bottom line. That is the something relevant to understand, something relevant to remember. So whenever someone asks that what is the purpose of normalization, you can directly say the purpose of normalization is to eliminate these anomalies. These anomalies are occurring because of redundant values, null values, because of all these things, right? And it will, so whenever we decompose this, it will naturally eliminate these possible anomalies, and it really guarantees that we will not lose any FD. So that is very important part. We will be discussing it along with the normalization process. why it is important to have this kind of normalization की जो FDs होंगी जो आपने मेन रिलेशन में ड्रॉ की है, तो जब आप उसको मेन रिलेशन से सब रिलेशन में ब्रेक करेंगे तो जो FDs फर्स्ट रिलेशन में थी उनको आप ब्रेक नहीं करेंगे, उनको आप लूज नहीं करेंगे। ऐसा ना हो कि थे तो सभी एट्रीब्यूट एक ही टेबल में थे उस टाइम, तो आपने FDs बना ली 1 2 3, उसके जब उसको आपने सब रिलेशन में ब्रेक किया, रिलेशन 1 रिलेशन 2, तो नेचुरली हर एट्रीब्यूट को तो आप दो जगह कॉपी नहीं करोगे, कुछ एट्रीब्यूट फर्स्ट में जाएंगे, कुछ एट्रीब्यूट सेकंड रिलेशन में जाएंगे। So in this process of decomposition, if you again derive the FDs, you should not lose any FD of the basic relation. तो वो चीज इंपॉर्टेंट रहेगी, तो हम देखेंगे कि what is the effect of that. Right. So now let's go to the this summarized view of normalization. So let me properly place it now. Okay, so here you can see we have given this basically process flow. So initially we will begin with this unnormalized data, basically on data state. So it is called referred as unnormalized. So the database table which we have created during this last you can say last two phases, it is referred as a unnormalized data relation, right? जो अभी तक इस डेटा डिजाइन के पहले का जो स्टेट होता है डेटा का, डेटाबेस टेबल का, वो होता है इट इज अननॉर्मलाइज्ड स्टेट. We have not formed any normalization, right? So there could be possibility of redundant values, null values, all those things, and we need to work upon those part, right? So when we begin this normalization process, initially we will have this unnormalization. Now we have to normalize into next possible state, which is called first normal form, right? So एक डेटा टेबल जो कि अननॉर्मलाइज है, सपोज यू वांट टू मेक इट more better way, more better relation, we have to normalize this database table into first normal form, right? And doing this process, going from unnormalized to first normal form, we will perform something. We will perform some constraint, or we will apply some constraint or condition on this database table. And if the database table is transformed in some way or perform something on database table, we can claim that this original database relation is now in the first normal form. Similarly, now we have reached in the first normal form here, and if we want to check the condition for second normal form on this database table, which is currently on the first normal form, you will be checking for the other conditions which are defined in the second normal form. So this whole process of normalization is basically one directional process, right? And so our objective of normalization is to achieve the highest normal form, right? That should be the objective. कि अगर आपका डेटाबेस टेबल जो था वो अनॉर्मलाइज था, उसको आप पहले फर्स्ट में ले जाएंगे, फर्स्ट के बाद सेकंड में ले जाएंगे, सेकंड के बाद थर्ड ले जाएंगे, और थर्ड के बाद हो सकता है BCNF में ले जाएं, which is the fourth normal form, which is the BCNF specific normal form, right? So objective of a database designer or database programmer is to achieve the highest normal form for a database table. Highest normal forms मतलब ये है कि जब आप उसको उसके हाईएस्ट नॉर्मल फॉर्म में ले जाएंगे थर्ड या BCNF में, then only that database table will become more efficient. You can easily access or you can easily manipulate the data without concerning about anything. So it is a kind of automatic process कि जब आप उसको उसके हाईएस्ट फॉर्म में ले जाएंगे, then it will automatically become efficient. Then it will automatically become a database table for efficient access, to support efficient access, right? So that's the objective will be. Now we will be going to understand each and every normal form by looking at the internal process of its normal form, right? So along with it, we will be identifying or discussing the conditions or definition or constraint defined on each normal form. So as you can see, the condition for first normal form. So first normal form is nothing but it is a simple condition. It says for a database table to be in the first normal form, you can see for the database to be in the first normal form, you need to ensure that all the values are atomic, right? So atomic means atomic means that value should not be divisible further, right? So the first normal form says whenever a database table is, so because we are in the first normal form, means this is the first normal form state, this is the unnormalized state. So initially we start with the basic database table. Now if you want to make this basic database table in the first normal form, you should be looking for this condition, whether this database table is having any multi-value or any composite value attribute or values itself. Like if you see in this database table project, you can see in the attribute project number there is no atomic value. Multi-values are the value which are having multiple values actually, and composite are the values where we have multiple value. Like in the case of address field, address attribute, we could have house number, state, and other things. So we can those values are also not allowed. So this is the original relation given. This is the original relation given project. Initially, it is a normalized. It is not having or it is not qualifying any condition, any normal form condition. So if you see in the attribute project location, if you see this value is atomic, it does not have any second value. It is having only one single value, right? So let me make this. It is not a specific value or a special value. Yeah, so you can see this the first attribute is not having any non-atomic or any composite, but in the second row, basically tuple, you can see there is this multi-value in the second tuple, because we are having this NCR, DL, and CHE, three project location values for this particular project. Similarly, if you see in the project number 333 for maintenance, we have two locations, NCR and Mumbai. So this whole remaining tuples, it does not have any multi-values. So for this particular database table, you can see or you can claim that, sir, this database table is not in the first normal form because it is not fulfilled or it is not basically adapting or it is not following or it is not qualifying the condition of first normal form. And what is the condition of first normal form? If it should not have any multi-valued, it should not having multi-valued as composite value in the relation, right? So if certain database table is given to you, you can immediately identify that this database table is in the first normal form or not by looking at the values. And if it is having any value like multi-value or multi-composite value, you can clearly or straight away say that this is not a first normal form relation, right? It should be very clear to you now. So atomic value, we have said atomic value means values which cannot be divisible. So like in project number, you cannot divide this value, you cannot split these values. These are some kind of atomic values, right? But in case of project location, these value can be separated on the, because these are the three different values. So this we cannot say that this attribute is having atomic value. We cannot claim that because for these two tuples we're having multiple values, right? Now so this is the problem, like because of these two attributes, tuple values, and due to this project location attribute, this whole relation database table is not in the first normal form, and condition first normal form is clear to you now. Now what is the solution? So suppose we want to decompose this relation and make to the first normal form, you should be handling it. So आपको अचीव क्या करना है कि हर एक सेल पे एक atomic value हो. So there are three ways to achieve it. So like in this tuple, we are having three values. Now what is the solution for it? What is the way to achieve this atomicity on each and every cell? So there are three possible approaches for it. So basically there are three approaches to achieve the first normal form of for a database table, right? So there are three strategies. The first approach says you can have by splitting it. So you can have approach by splitting this attribute, जो project location attribute है, उसके दो और जितने भी multi valued है उनके लिए सबके लिए एक अलग attributes create कर दीजिए. That is the first solution. So first approach says initially we have one project location attribute. Now we can create other project location attributes, right? So now you can see for this attribute we are having, for this particular attribute where we are having three locations, NCR, DL, and CHE, we have created these number of attributes. Same attribute we have replicated simply. Similarly for 333 maintenance, we have created. So now it is okay because we have already created three attributes. So it is not time. So you can see now, you can see by adapting approach 1, you can claim that now this whole database table is in the first normal form because it does not have any multi-valued attribute, multi-valued value, right? So that is the first solution. Now, so this approach is having certain issues. Issues are like we are having null values. Null values. You can see the null values. So this approach is having that number of null values in the main concern in this approach, right? Now let's go for the second solution. Second solution is what we can have this. So this is your original relation. This is the first. This is the original relation. Now, based on the second approach, what we have done, we have simply splitted it. So you can see for 2 to 2, these 3 row has been created. Just because we are having three different project locations, we have created 3 different tuples. So we are having these kind of arrangement for the as a second solution. Now, what is the possible basically limitation of this approach is that we are having these repeated, now redundant copies has been created for this. Because of this approach, these redundant values of दो प्रोजेक्ट नंबर एंड प्रोजेक्ट नेम तो मल्टी वैल्यूड थे ही नहीं, लेकिन हमने इसको क्या कर दिया, because to take care of these values, these multi-valued in project location, we have created multiple redundant copies of these 2 attributes. So this is again not so good approach. So we are going for the third approach. There we have simply created a different database table, right? So this is your initial table. This is your initial table, right? You can see now we have done one thing. We have created this. So now this particular database table, the first original one, has been split into 2 database tables. First table is having what? First table is having the project number and project name. These 2 attributes are placed into this table number 1, and the attribute which is multi-valued, it is placed in the table 2, right? You can see in the table 2 we have placed project location and project number. So this is, I think, we have done during these mapping of ERD into logical schema also, right? So all the multi-valued attribute has been placed in a different table along with the primary key of the table, right? So this third approach is more suitable because it is not creating those kind of null values or those kind of unnecessary repeating of value. Yes, it is having this kind of elements, like we are having this instance, we are having this instance, it is there, but it is having some limited scale, right? So to normalize a database relation into the first normal form, you can adopt this approach. So whenever you found that a database table is having this multi-valued presence of certain values, you can immediately create a separate relation for those values, right? Okay, so I hope it is clear to you now. Now, for a given database table, by looking at the values, you can easily understand that whether this particular database table is achieving or adapting first normal form condition or not. If it is not, you can immediately derive, or you can immediately perform this normalization and achieve the database table with these conditions following. So you can directly achieve the database table which is in the first normal form, right? So I hope till this point things are clear, concepts are clear. Now we are moving towards a different normal form, second normal form, right? Second normal form. So second normal form is having different conditions naturally. So if you want to, so now we have normalized a given database table into first normal form, and if you're really interested to normalize this database table into the second normal form, because now we are looking for normalizing this database table into second normal form, you can immediately identify, or you can immediately find out that whether this database table is in the first normal form or not. Because एक database table second normal form में है, उसके पहले आपको चेक करना पड़ेगा कि वो database table, database relation first normal form condition meet कर रहा है या नहीं, right? Because this kind of preconditions. तो अगर database table second normal form में होना है उसको, तो first में होना ही चाहिए उसको. It is like precondition, and it is like one way approach, right? So so we are assuming that a given database table is in the first normal form. and to check that database table is in the first normal form or not, you need to see the condition of first normal form, which says atomic values, right? So now I'm assuming that a database table is in the first normal form. Now I can check for the second normal form condition. And what is the condition of second normal form says? So now after this first normal form, there will be the role of candidate key. There will be the role of right. So second normal form states that a table, a database table, should not have any functional dependency which will create a partial dependency among key means candidate key and non-key. So now this particular term is referred or used. It is called key and non-key, prime key and non-prime key. So there is these terms used in the different books. So all the attributes. So now you can have this clarification that all the attributes of a database table, all the attributes of a set of functional dependency which are part of candidate key, all the attributes which are part of candidate key are called prime key or key, right? All the attributes which are not part of candidate key are called non-prime key. It should be very clear to you, right? So the second normal form says there should be no partial dependency between key and non-key, right? So अभी हम उसको देखेंगे कैसे होने वाला है. Now let's take this particular database table. So this database table is, so you can see based on this database instance, I can claim that this normal form project employee is in the first normal form, already in the first normal form, because it is not having any multi-value composite value. It is for sure, right? So now how to normalize this given database table into the second normal form and how to check it? हो सकता है कि ऑलरेडी सेकंड में हो, तो वो आपको चेक करना पड़ेगा. अगर सेकंड नॉर्मल फॉर्म की कंडीशन नहीं मीट कर रहा, then only we will be normalizing this database relation into second normal form. We will be normalize this database table to make it the adaptable to the second normal form, right? So based on this database values which is in the first normal form, we have derived these FDs, right? So ऐसा assume करते हैं कि ये जो FDs हैं ये इस database table में होल्ड कर रही है कि फॉलो कर रही है, derived हो रही है, ठीक है. Now you can see we have derived 3 FDs. So SSN and project number is determining hours. Second FD says SSN determining E name. Third FD says P number determining P name and E location. So these are the 3 possible FDs. Now based on these FDs, because this is the first set of FD which we have determining. Now what is the second task? Second task is to perform the candidate key. What is the candidate key of these 3 FDs? Based on these 3 FDs of this database table, what are the candidate key possible? So you can see SSN and project number. SSN and project number is the only possible and best optimal candidate key. So you can see we have derived the candidate key now. So it is very clear that the current normal form, current highest normal form is the first normal form that we have verified. Now you need to see whether this database table is following the condition of second normal form or not. So what we found, we will look for the FDs by using the candidate key. So to check the normal form condition, second normal form condition, you need to use the candidate key, because in the definition of second normal form, it is said that there should be no partial dependency between key attributes and non-key. So what are the key attributes? Out of these FDs, we have defined this candidate key, and we can claim that these are key attributes. These are SSN and this, and remaining will be non-key, right? Now we have clearly identified that out of these 6 different attributes, we have 6 different attributes: SSN, project number, hours, E name, P name, and project location. So out of these 6 attributes, SSN and P number are the key attribute. SSN and P number are key attributes. All the remaining attributes like hours, E name, P name, and P locations are non-key. They are not the part of candidate key. So it should not be. So between these two sets, key and non-key, there should be no partial dependency. So partial dependency means what? Let's take and let's check which FD, due to which FD this condition is not following, right? So if you see in the first FD, FD1 and FD1, it is like SSN derives P number. So SSN and P number deriving Rs. So Rs is a non-key, and SSN and P number is a key, right? So it is following the condition of second normal form, because your key attribute SSN and P number is deriving a non-key. It is okay. It is not having any issue. Second FD says SSN derives E name. Now you can see SSN deriving E name. E name is a non-key. I can say that. I can see that also. But SSN is deriving, only SSN is deriving E name. So SSN is a part of key. SSN is a part of a candidate key, and it is deriving E name. So I can say that this FD2 is violating the condition of normal form, second normal form, because SSN is not a key. It is a partial key, I can say, because हमारे इस database table के लिए, इस FD set के लिए key is candidate key is what? SSN and P number. It is not SSN. So अगर आप SSN और P number में केवल SSN को use करोगे, P number को use करोगे, तो it will become partial key. पूरी key use नहीं कर रहे ना. So you can see in the FD2, a partial key SSN is deriving or defining a relationship with non-key. So FD2 is not fulfilling the condition. FD1 तो कर ही रही है. Again, you can see FD3. You can see FD3, which says P number. Again, you're using P number. P number is a partial key. It is not a. It is part of prime. It is part of candidate key, but it is not the whole key. P number is a partial key. So now you can see. So this P number is deriving non-key attribute. So it is again violating the condition of second normal form. So you can claim that I have checked the second normal form condition on this database table and its FDs and derived candidate key. And due to this condition due to this FD2 and FD3, this database table currently is not in the second normal form, because in the FD2 and FD3, these partial keys are being used to determine the non-key attribute. तो आपको क्या कहना है कि partial key वही है. So it should be, so all these non-key and key should be not having this partial determination. That's what the typical meaning is. तो अब ये प्रॉब्लम हमें FD2 FD3 में है, तो उसका सोल्यूशन क्या है? एक डेटाबेस टेबल में FDs है, और जो भी FD सेकेंड नॉर्मल फॉर्म की कंडीशन वायलेट कर रहा है, वो फुलफिल नहीं कर रहा है, उस FD को सेपरेट टेबल में रखना आपको. That's the simple purpose. So FD1 will be kept in one, because FD1 is following the condition. So FD1 will be kept in one database table. FD2 will be kept into the different database table. FD3 is again violating, so FD3 will be kept into the three different relations. So basically, this whole new database, this database table will be now split it or normalized into 2 to 3 different database tables, right? Now, so there is this explanation given, so you can read it after that. Now, so how to normalize? Normalization is like this. That's what I'm discussing. So based on this FD1, because FD1 is following the condition of second normal form, so the database attributes which are following in the FD1 are kept into R11 relation, that is first relation. Similarly, FD2 is kept in one relation, might be in the R11, FD2 is kept in R11, and FD3 is kept into this R12, and FD1, which is following the condition of second normal form, is kept into R13, something like that. So all those, so now you can have this kind of generalized rule whenever our database table is not following the second normal form, and we have identified that based on this candidate key, these are the FDs which are following. So you need to keep all those FDs, all those attributes into the one relation which are following the condition of second normal form, and each and every FD which is creating this problem, which is violating the second normal form, should be kept in different tables. ऐसा नहीं किया हमने कि FD2 FD3 को एक भर दिया बिकॉज दोनों ही नहीं कर रहे, नहीं, जो भी FDs वायलेट कर रही कंडीशन सेकेंड नॉर्मल फॉर्म के should be keep into the different database tables, right? So this is this basic database table is now normalized into the second normal form, and these are the sub tables has been created. Now before going to the final comment, we have performed this normalization and we have kept these one single database table into 3 different subtables. Now we have to check कि जो हमने decomposition किया है, जो normalization किया है, वो ठीक है कि नहीं. That is the kind of condition check. Now these 2 conditions are called decomposition constraints. अब constraint क्या है कि whatever decomposition we have performed, whatever condition we have performed, it should have these 2 properties: dependency preservation and lossless. जो हमने normalization किया है उसमें ये दोनों conditions fulfill होनी चाहिए. Basically that's the theories. तो हमने क्या कहा था कि जब भी हमने basic database table लिया, उसकी FDs ली, उसको normalize किया different tables में, और different table में जो आपने कर दिया, अब हमने क्या किया है कि R1 में SSN और E number है, E name है. R12 में we have these 3 attributes. In R13 we have these 3 attributes. Now again we have to derive the FDs. So if you derive the FDs, you can clearly claim that in this relation R11 there is this FD called SSN determining E name. That will be there. Similarly for R12, this because we have 3 attributes SSN, P number, R, so you can claim this FD SSN and P number determines R will be there. Similarly for R13, these 3 FD will be there. So you can claim that we are not losing any FD. जो आपकी FDs original relation में थी before this second normal form normalization, और जो आपने normalize कर दिया उसमें. So if we are not losing any FD, you can claim that this decomposition normalization is a dependency preserving. It is preserving, it is maintaining each and every FD. Secondly, we have to see lossless, right? Lossless means now after this decomposition, we have not lost any FD. That's one part. Second, between each and every relation, R11 and R12, it should be having at least one attribute common. Like between R11, R12, R12, R13. So pair of जो tables हमने create किए हैं, उन pair of tables के में at least एक attribute common होना चाहिए to create the join, right? और अगर ये नहीं होगा तो क्या होगा? कार्टेशियन बनेगा, कार्टेशियन प्रोडक्ट. अगर 2 टेबल्स के बीच में कोई एट्रीब्यूट कॉमन नहीं रहेगा तो इट विल क्रिएट अ कार्टेशियन प्रोडक्ट, एंड दैट इज नॉट कंसीडर्ड एज अ गुड डिकम्पोजिशन, राइट? सो व्हेनेवर वी नॉर्मलाइज अ डेटाबेस टेबल, सो नॉर्मलाइजेशन के बाद आपको ये चेक करना है, अगर ये दोनों कंडीशन यस हैं, देन ओनली यू कैन क्लेम दैट दिस इज द बेस्ट सूटेबल नॉर्मल फॉर्म. अब जैसे हमने इस डेटाबेस टेबल को किया है, इसमें हमने क्लेम कर दिया कि इट इज हैविंग डिपेंडेंसी प्रिजर्वेशन, इट इज नॉट लॉसिंग एनी एफडी, एंड इट इज हैविंग at least a common attribute between each the pair of tables. So you can claim that this decomposition is the best decomposition, this is the best normal form for this database table. That's it, that's the whole story. Similarly, now we have at least 10 minutes, so let's finish the third normal form also, right? So this theory of the third normal form is based on the condition like in the second normal form. The whole theory is that you should be having full dependency between key and non-key. You should be not having any partial dependency between key and non-key. Similarly, in the third normal form, there is this basic precondition. Naturally, first condition is that कि जब आप थर्ड नॉर्मल फॉर्म को चेक कर रहे हो, थर्ड नॉर्मल फॉर्म में नॉर्मलाइज कर रहे हो, तो रिलेशन आपका सेकंड नॉर्मल फॉर्म में होना चाहिए. जो अभी हमने डिस्कस किया, तो आपका डेटाबेस टेबल या उसकी एफडी सेट है, उसकी कैंडिडेट की, उन सबको लेकर आप चेक करेंगे, तो दैट रिलेशन शुड बी इन द सेकंड नॉर्मल फॉर्म. बट नाउ यू हैव टू सी व्हाट इज द कंडीशन ऑफ थर्ड नॉर्मल फॉर्म. द कंडीशन फॉर द थर्ड नॉर्मल फॉर्म इज दैट there should be no transitive dependency between key and non-key. Again, now we are using again candidate key and set of attributes in the candidate key, but condition is now there should be no transitive dependency. Transitive dependency क्या है? सो सपोज कुछ एफडीज दी हुई हैं, उसमें ऐसा है कि A determines B, B determines C, right? And if A is a, so अगर तीन FDs, दो FDs हैं, A determines B and B determines C, and for these two set of FD, A is, suppose A is a candidate key. तो इसमें क्या हो रहा है कि A is a candidate key means A is a prime attribute and B and C are non-prime. But just because there is this transitive A to B and B to C, you can easily determine A to C. So you are reaching C by using B. अब B is again a non-prime. So ऐसा नहीं हो सकता है कि आपने एक की एट्रीब्यूट को या प्राइम एट्रीब्यूट को यूज करके दूसरे एक नॉन प्राइम डिटरमाइन किया जो कि डायरेक्टली नहीं है, and you are determining C by using B, right? And this is not allowed. This is what something referred as a transitive dependency. So the condition in third normal says there should be no transitive dependency between key and non-key, right? Now let's have a brief idea how to see. Now we have taken this different table, and we are assuming that this EMP department table is qualifying the second normal form condition, and we have initially derived some FDs. So we have FD1, FD2, FD3, and FD4. 4 FDs we have defined, and we have identified that SSN is the candidate key for this. So candidate key is naturally we have derived initially. So SSN is the primary key, candidate key for that. Other than SSN attribute, all the attributes 1, 2, 3, 4, 5, all these 5 attributes, ename, birth date, D number, D location, DM, GRSSN are the non-prime, non-key attributes, right? Now we will check the condition for third normal form. A condition for third normal form is that there should be no transitive dependency between key and non-key. You should be not determining a non-key using a non-key, something like that, right? So here key is SSN. So first FD is saying what? SSN determines ename and birth date. So it is okay. FD1 is following the condition because we are using candidate key and we are not determining anything as of now. Now if we check for the FD2 says SSN determines D number. It is okay. We are determining D number, right? Now you see it carefully. If you see FD3 and FD4, FD4 says FD3 says D number determines DMGRSSN. D number determines D location. So now you can see that because in FD2 SSN is giving you the D number. SSN is determining D number, and because D number is used to determine D number to SSN and D number to D location. So I can claim that by only having D number, which is a non-key, I can determine DMGRSSN and D location, right? So basically these two FD3 and FD4 are the problems. Because of these, I can determining a non-key. SSN is able to determine DMGRSSN, D location, 2 attributes, just because it is having the access to D number. So but because of these FD3 and FD4, we can determining the non-key attributes. We can establish this transitive dependency. This should be not acceptable. This should be not acceptable. This will be removed. So now basically these two FDs are the problem. So you need to perform the normalization by keeping these two FD in point. Because of these two FD, FD3 and FD4, we are not able to claim that this database relation is in the third normal form. So again practice वही होगी कि जो भी qualify कर रहे हैं FD1, FD2 will be kept in one relation, and all the FDs which are not following the condition will be moved to different relation, right? और वो सब करने के बाद आप क्या करेंगे? वही condition check करेंगे, functional dependency preserving and that lossless join or not, right? And that is after that you can claim that this database table is in the third normal form, same, right? So that's the basic philosophy. So now you should be. So now I'm stopping the share option. So if you have any question or queries, you can immediately post to me or you can raise the question. So the basic philosophy of normalization is to basically decompose the database relation, and and to perform this decomposition, we'll have the definition of normal forms, right? So we have taken the definition of first normal form. There we are removing the multi-valued as composite value and achieve this atomicity on each and every cell, each and every value. After that, we have gone for the second normal form. Second normal form says there should be no partiality between non-key and key. There should be a full dependence between key and non-key. That's what the simple purpose. Similarly, if you go for third normal form, it says there should be no transitive dependency between key and non-key, right? And the process of normalization is same in all the normal form. So अभी हमने कहा फर्स्ट से सेकंड में गए, सेकंड से थर्ड में गए, थर्ड से BCNF में भी जा सकते हैं. So थर्ड से BCNF में कब जाएंगे? कोई डेटाबेस टेबल थर्ड नॉर्मल फॉर्म में ऑलरेडी है, तो उसको BCNF में कैसे क्लेम करेंगे? उसका प्रोसेस सिंपल है. You need to follow the condition of BCNF. BCNF says each and every determinant should be the candidate key. That is the simple condition of BCNF. So I hope the things discussed in the today lecture are clear to you. Now you need to do one thing. You need to take different